Hi everyone, in this video we are going to discuss about the third theorem from geometry of circle. The theorem says any angle inscribed in a semicircle is a right angle. So as you can see in the diagram, if we have a circle like this and AB is the diameter, then of course the upper part can be considered a semicircle, and there we have an inscribed angle at the point C, and we have to prove that that angle is actually 90 degree. So essentially we have to prove that an angle subtended by a diameter on the circumference of course is equal to 90 degree. So let's get started with the proof. For us to be able to do the proof, I need to join the point C with the center. Let's suppose the line segment CD is the line segment that's joining the point C with the center O. Now let's look at the triangle CAO. This triangle has OA equals OC because they are the radius of the circle. That means this is an isosceles triangle. That means angle OAC and angle OCA will be equal, and let's assume that they are alpha degree each. I have noted that in the diagram that angle OAC and angle OCA, they both are equal to alpha degree. So in that case, can we consider angle AOD as an exterior angle of the triangle? And this exterior angle will be equal to the sum of the two farthest interior angle. In this case they are alpha. So angle AOD will be equal to angle OAC plus angle OCA, which will be equal to alpha plus alpha, and that will be equal to 2 times alpha. Next, let's look at the triangle COB. Here again, OB will be equal to OC, and each of them is equal to the radius of the circle. So this triangle, the triangle COB, is also an isosceles triangle. That means angle OCB and angle OBC will be equal, and let's call them theta. Let's assume that each of those angles is equal to theta degree. So in that case, can we consider that the angle BOD is an exterior angle of the triangle, and this exterior angle will be equal to the sum of the two farthest interior angles, and that will be theta plus theta, that will be equal to 2 times theta. So angle BOD is equal to 2 times theta. Now if you think about the straight angle which is at the center O on the lower side of the diameter, that straight angle is actually the sum of the angle AOD and angle BOD. If we add them up, that will become the straight angle, that will be 180 degree. So that's exactly what I have noted here on the left hand side, that angle AOD plus angle BOD can be written as 180 degree. Now what is angle AOD? Well, angle AOD is equal to 2 times alpha and angle BOD is equal to 2 times theta. So in place of angle AOD and angle BOD, I have written 2 times alpha and 2 times theta, and their sum is equal to 180 degree. And from here, if we take 2 as a common factor out, then it would be 2 times alpha plus theta is equal to 180 degree. And from here, if we divide both sides by a 2, we are going to get alpha plus theta is equal to 90 degree. Now if you think about it, what is alpha? Well, alpha is also equal to angle ACO. And how about theta? Well, theta is equal to angle BCO. So in place of alpha and theta, we can easily write angle ACO and angle BCO, and that's exactly what I have done. I have written as angle ACO plus angle BCO is equal to 90 degree. And now if you think about the sum of those two angles, that is nothing but the angle ACB, and that is the inscribed angle. So angle ACB turns out to be 90 degree, and that's exactly what we needed to prove. And using the same technique, we can prove any of the inscribed angle subtended by a diameter of any circle will be equal to 90 degree. As long as the angle is subtended in the semicircle by a diameter, that angle will be equal to 90 degree. This brings us to the end of this video. In the next video, we are going to discuss about another theorem. I hope everything made sense here. Thank you for watching. See you in the next video.